I want to, do you consider it's good repetition again the step in the problem number one or not? Because we almost finished, you know? Good morning, Yancy, Maria. Okay. Let me ask a question. The the video in YouTube is useful or no? Oh, music. Yes. Okay, Safra is a yes. Okay. Did you see Safra? The Lustig is a yes. Okay. 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 Super. Anytime. When I finish, I will post it. That video. Safra, you cannot see the whiteboard. Safra, maybe the problem is can you get in? Try to go out and get in again, right? Sign up using the new link that I sent to you. No the old. O sea, every day I send new link. Okay? The rest of the students saw very well the whiteboard or no? Yes, I using the new link from the email. Okay. So say okay, recommendation. Sometimes happen, I don't know why, depending your computer, depending your Lucy is yes, I can see the whiteboard. So sign up and again get starting again. I don't know why sometimes happen for some students this situation. Es que there are a lot of technological problems, no? Internet connection, the computer of the some student is not good. No. Okay, ready, guys. Ready. Safra, are you there again? Or no? Or not yet? Okay. Are you ready to pay attention? Are you ready? Everyone is ready to pay attention to start? Okay. Okay. Jasmine, no? Jasmine, I remember your name. Jasmine. Okay. Entonces, the first step, always when you face that problem, is factorization, the polynomial in the top, and the polynomial in the bottom, no? In this case, in the top we have monomial, stay the same. And the bottom we have the differences of the square. And the factorization is too easy, is 2 plus or minus. Okay, this is the original and this is the factory form. In this moment you see that we have no common factor to simplification. No. That means that we have no whole. It's obvious that we have no whole. We have no whole. Okay? When some factor is cancelled, you have to so the factor can involve the number is cancelled, is gone, is a whole. In this case, no. Okay, the second step is find the y-intercept, que es super easy. Es evaluar en 0. Es obvio que es 0 because 4 times 0 over 0 square minus 4 0 divided by -4 is 0. Therefore, the point is the famous point 0,0. 0,0 is y-intercept, and when this situation happens, when the x is 0 and y is 0, it's because it's both. It's x-intercept and y-intercept. But maybe we have another x-intercept. Remember, what is the formula? Well, the formula is f of x equal to 0. In our particular rational function, remember rational function, we can interpret it like a p of x divided by q of x. We have two polynomials, no? Polynomial at the top, polynomial at the bottom. Actually, when it's 0, is equivalent to say polynomial in the top equal to 0. Polynomial in the top is just the monomial. And again, it's a coincidence that x is 0. Therefore, the point is 0,0 because the supposition was that y was 0, and now the answer is x equals 0. Okay, super. So basically, step 1, step 2, step 3. Step 4 is the vertical asymptote. And the vertical asymptote, what is the formula for finding the vertical asymptote? It's cube x equal to 0. And the polynomial in the bottom, that you using, if you want, either way, the original or the factor form. Well, I suppose the factor form is easier because basically it's two factors, x plus 2, x minus 2, equal to 0. It's obvious that the solution is x equal to positive and x equal minus 2. So we have two vertical asymptotes. And this is a moment, I don't know why I get like to start doing the graph by hand. Of course, just in case, I will check in this one, no? The last moment. This is my x-axis. We discover against 0, we have the point 0,0. And n2, 1, 2, and -2, -2, and positive, we have two vertical asymptotes. Okay? Super. Remember, this allows us, this sketch allows us to selection the additional point I need to plug in. But this is the last step. Step 5 is the horizontal, or line. Remember, I copy again my expression, que is 4x over x squared minus 4. We are doing the analysis of the degree. Degree of the polynomial in the top is 1. Degree of the polynomial in the bottom is 2. Entonces I know by memory the analysis of the degree is that when we have horizontal, when the degree is the same, or when the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator, no? In this case, 2 and 1, yes. So this is like a special. Remember, we have regular horizontal when it's the same degree, and we have a special when the degree of the denominator is greater than the degree of the numerator. Pero degree greater than in any, suppose que es 1, 3, 1, 4. So now, in this case, is special, always the horizontal asymptote is at y equals 0. Y equals 0 is exactly the horizontal line coincident with the x-axis. Okay, this is the horizontal asymptote. Y is 0. Remember, always when you try to find horizontal asymptote, you investigate if the curve crosses or not the horizontal asymptote. In this case, it's obvious que yes, cross at the famous point 0,0, no? Que we get at the beginning. But the regular or the traditional way to find that if you take the expression either way, and you enforce it to be 0. But this equation look like similar and the equation that we did before when we solving the x-intercept. Look, that part. Okay, this is a coincidence. No, all will happen because it's 0. Si it's another number, no. Ok, entonces es x igual 0. O sea, x igual 0, therefore, the 0,0 point is a lot of things. Is x in a set, y in a set, and also is the famous point in which the curve crosses the horizontal. Okay, super. What is the next step? Well, the next step is testing the symmetry, no? Testing the symmetry. The symmetry, remember, you are making reflection. Reflection, you take the original function, you replace x for negative x. Let's do it. It's 4 negative x divided by negative x squared minus 4. And the top we have minus 4x. And the bottom is square stay the same, it's positive. Because negative 1 is square positive 1, and positive 1 is invisible factor, no? Now, if you want, you put to see much better the negative in the front. And you compare this expression and our original expression. You see that they are very, very similar, except que es opposite sign. That the y value is opposite sign. And it's a classical odd function. But it's a fantastic, I take advantage of this, because when you try to evaluate a different point, the positive part is similar, no equal con the even part. When they say similar, it's because it's opposite sign, right? It's opposite sign, the y value. And I take advantage this symmetry. Okay, number 7 is the selection and evaluate additional points. How many? My opinion, I go back to this sketch. I see the partition that we have in the x-axis is 1 x-intercept and 2 vertical asymptotes. If, for example, I select in each interval one, let me call testing point or additional point. I suppose I select in between 0 and 2, I select 1 because I like. And between no, after 2, 3, 4, 5, 6. Okay, I select 4. Well, it's okay. 4, 3. Okay, not necessarily 3. So this is the minimum point because I know this is 4. Because I know that the answer in negative 1 is exactly the same of the positive 1, but opposite sign because my function is opposite function. And the answer in negative 4, negative 3, negative 4 is exactly the same of the positive 4, but opposite. So this is the minimum number of additional points that you need to investigate. You investigate more is much better. Okay, additional points. So you evaluate, for example, in 1, the function, the original function is 4 times 1 over 1 squared minus 4. This is 4 divided by negative 3. Negative 4/3. In decimal approximation is negative 1.3 repeated. Because I know the fact. So we have at least 1 point, que es the point 1, comma, and negative 1.3 repeated. I write in decimal approximation because it's easy to see the location and when you plot the point. No? That's okay. In decimal, you can express it in fraction when this. And likewise, in negative 1, we have positive 1.3. Because the function, again, repetition, again, the idea for the symmetry, very important, is hot. Suppose 4. It was the other que I select totally arbitrary, another student select another, and the answer is perfect, no? So 4 times 3 over 3 squared minus 4. This is 12. This is 9. This is 4. This is 5. 12 over 5. And 12 over 5 is in decimal 2.4. So the famous point is the point 4, 2.4 and negative 4, negative 2. Opposite. They take advantage. Symmetry. Any question, guys? What is the rest? Well, the rest is put in decimals, and you can see very well the graph. I like so much that you emphasize the asymptote. You put in black color dotted line. Let me see in decimal. I have decimal here. Let me share the screen for decimals. Oh, decimal. This wasn't. Yeah, example 5. So we're doing today 5, 6, 7, and 8. Okay, something like that. Okay, evaluate. Okay, look at that. The famous 0,0, that's the y and z. We have two vertical asymptotes and positive 2 and negative 2. We have one horizontal and 0, y equals 0. Entonces I evaluate en different points. En 1 and negative 1, en 1.3 repeated, y en 3, no, en 4, y en 3. Okay, okay. Because I included one additional point. Okay, look at this. I copied the original. I copy the famous point, 0,0, x equal 2, and I change the color to black color, no? And the point, look, the point, the collection of the point, additional point is. Any question, guys? Confusing, clear? Fantastic, amazing, wonderful. You understand very well? Clear, Yasmin say, clear. Okay, Yasmin. Any other opinion, any other thing? Okay. Clear, crystal clear. Okay, good. Yeah, I have 4 examples today. This is the first one. Number 1. Okay, this example I suppose I create, no, I select. Okay, include everything. In the last one we have surprise. Okay, let me share. Do you see whiteboard or no? Okay, no. Oh. Okay, I understand. Oh, okay, let me try again. Whiteboard? Whiteboard now? Yes. Let's doing the problem number 2. Problem number 2 is the function g. In the top, we have the polynomial 2x squared minus 3x minus 5. In the bottom, we have another polynomial, x squared. Well, let's do in the step 1. Step 1, as always, I try to do my best to factorization of the polynomial in the top and factorization of the polynomial in the bottom. Remember, we can use any technique of that factorization, including synthetic division, no? That you use in your imagination. Okay, in this case, well, in this case it's easy. Professor, I'll write back. My computer is freezing. Wow. Okay. Because the internet is slow, no? Or no? Internet is a little bit slow now, huh? Or no? Let me see. No, it's okay. Internet have quality. Everyone follow me or no? Come on, I need to. Okay, it's just my computer. Okay, Laura. Okay. Remember, Laura, this is recording. No, it's okay. This is recording. Anything you lost, also you. Okay. Okay. Step one is factorization. Follow me. Okay, follow me. Step one is factorization. Entonces I copy the polynomial on the top, que es 2x squared. I focus in this guy. There are many ways to do the factorization. But in my opinion, the easy way is factorization by grouping. You multiplication 2 and 5, 10. I don't care the sign. The sign is not important in this procedure. And the factor que suppose que involved in the problem is 5 times 2, because 5 times 2 is 10, and 5 minus 2 is 3. Now, you copy the first, exactly the same, and you split 3 using 5 and 2, like that, minus 5x plus 2x, minus 5, something like that. This is equivalent expression. The only thing I did was split 3 using 5 and 2, but we are ready to apply factorization by grouping. The first couple, the great common factor is x, 2x plus 5, minus 5, sorry, and the second couple, the great common factor is 1, 2x minus 5. Now, I saw that the factor 2x minus 5 repeated, I factor out, and we have x plus 1. Okay? And this is the factorization of the polynomial in the top. Any question, guys? Maybe you are doing different. In the high school, another teacher is playing different. Okay, no, I don't care the way. I care the final answer. 2x minus 5, x plus 1. Another student don't like factorization, entonces prefer solving the equation using the quadratic formula, and you have some idea of the factorization. But okay, either way. The polynomial and the denominator, this is the sum of a square. It's a binomial. Yeah, I know very well that this is prime expression. Okay? I know very well that x squared minus 1 is the classical difference of a square. Nice. But when it's plus, no. When it's plus, it's imaginary, right? It's imaginary, and we can factorization in the imaginary or complex field, but not in the real field. Que es el field that we are working in this example, no? Entonces, leave it like that. Don't touch. Everyone understand very well this? This is clear or no? This idea is clear or no? Come on, guys. Yes, answer me. Clear, way, super. Betancourt. Okay, Betancourt. Okay, Jasmine, clear, okay. Now we finish the step 1. The step 2 is find the famous y-intercept. What is the formula? Well, the formula is evaluate the function, que the name of the function is no f, it's g, evaluate 0. It's super easy because when you evaluate x, you replace x for 0, stay alive, in the top, -5. In the bottom, is 1. This is negative. The famous y-intercept is the point 0, -5. Good, very good. This is easy. It's okay. Step 3 is also easy. Let's find the x-intercept. Okay, this is important point. Extremely important. It's when the g of x is 0. Or in other words, when the polynomial in the top is p is 0. I take advantage que es already factorization. Y I copy only 2x minus 5, parenthesis, x plus 1. I separate using the zero factor property, x plus 1 equal to 0, therefore x is -1. and 2x minus 5 equals 0. 2x equals 5 divided by 2. X is equal 5 over 2, or if you prefer in decimal, it's 2.5. Okay, you put in decimal. Okay. Entonces, conclusion, we have to do x in a set at the point negative 1,0 and 2.5 or 5 over 2, either way, comma 0. Any question, guys? Any question? No question. Okay, now step 4. Step 4 is the verical asymptote, no? And verical asymptote, remember the mnemonic device to remember the formula for finding verical asymptote. You take the polynomial at the bottom equals 0. And the polynomial at the bottom is x squared plus 1. Wow, but this guy, I discovered que es prime is irreducible quadratic expression. And the reason is irreducible quadratic equation is when you try to solve this quadratic equation, the answer is imaginary or complex. Entonces, bueno, okay, suppose I don't know anything. Okay, I try to solve for x, I move 1 to the other side, apply square root both sides, is plus or minus 5. Entonces, me dice, wow, imaginary. Entonces, what is the interpretation of this? Es clásica in algebra. When you try to find something, it is something in this step 4 is very close, and you set out the equation, and the answer is imaginary or complex, that means that the verical asymptote do not exist. Okay? The complex is a guy that are living in another dimension, not in the real field. Therefore, in our dimension, do not exist. Exist, but in another dimension. Okay, therefore, you ignore in this problem. Any question? Step 5 is the horizontal or slant. What do you think? Remember, it's the analysis of the degree. Let me copy again my original function. My original function was 2x squared minus 3x minus 5 divided by x squared plus 1. Wow. Degree of the polynomial at the top is 2. Degree of the polynomial in the bottom is 2. Ooh, same degree. Does we have horizontal or no? What do you think? And this is regular horizontal or special horizontal? We have horizontal. Pero regular or special? Regular or special? Regular. By the way, the horizontal asymptote is the line. Y equals something. Y equal what? Special. Yasmin, you say special or regular? Special, remember, is when the degree of the denominator is greater than. Pero when the degree is the same, es regular. Bueno, I call. This is my, okay. Okay, entonces my next question is, at what value of the y is equal the horizontal asymptote? At y equal what? Two. And where come from that 2? Remember the idea for the dominant. Who is the monomial dominant in the top? This guy. Who is the monomial dominant in the bottom? This guy. Entonces, this and this together, it's obvious que se square cancel out, and the answer is just. This is the equation of the horizontal at y equal to. Okay, and that's it. No, I need to investigate I need to investigate if this function crosses or not the horizontal. Entonces, to investigate this, well, okay. I just copy 2x squared minus 3x minus 5 equal over, sorry, x squared plus 1 equal to. I set up this equation. So this equal to this. And maybe we have two possibilities. When you solve this equation, you find solution. Yes, entonces, that means that our curve in one specific point crosses the. Otherwise, no. See, we have no solution, entonces no, never cross. Okay, this is easy. You apply cross multiplication. You multiply 2 times this guy, that 2 times x squared plus 1. And the top part multiplied by 1 gets invisible. No? Multiplier, we have this situation. And you apply this trivial property to x squared plus 2 equal to x squared minus 3x minus 5. Oh, I like that. This is canceled. And stay alive. Let me continue here, guys. 2 is equal minus 3x minus 5. I move 5 to the other side. 2 plus 5 gets 7. X equal minus 3x divided by negative 3 both sides. X is equal minus 7 over 3. Okay, right away, I put in my calculator 7 over 3 is 7 division by 3 is 2.3 repeated. Minus 2.3 repeated. This is the x value. So the famous point is a point minus 2.3 repeated, comma something. Comma what? Comma what is the y value que corresponde in this case? Please help me. What is the y value? Huh? How you find the y value? Or how do you know what value? Hey, what's going on? Are you there? Oh, internet is disconnecting. Es two. Isn't it two? How do you know it's two? Because it's the point that we need to find. We need to find the intersecting with the y equals 2. Entonces es 2. Excellent. Es 2. O sea, en negative 2.3, 2, our curve crosses this. Okay. What is the next step? Well, unfortunately, we have no vertical asymptote. When you make a partition of the all real number line, the only information to make a partition of the x-axis is the x-intercept, because we have no vertical asymptote. Entonces, this is 0. We have in 2.5, 1, 2, 3 here. Again, 2.5, we have the intercept. And also a negative 1 here. Then, the additional point I select is in between this and this. I select, for example, I select a 1. 1 is good. Now you try to find easy, no complicated. And 5, this is 3, this is 4, and 5. I select, but another student maybe select 3 or select 4. I select 5. I don't know why. And here in the other direction, so before negative 1, maybe negative 2, but I select, I don't know why, negative 3. Oh, but I forgot something important. I forgot testing the symmetry of the function. It's step 6. Step 6 is testing the symmetry of the function. So you are making reflection. I come back to the original to the original function que was no f, o sea, it was g, pero g evalué en negative x, es 2 negative x squared minus 3 times negative x minus 5 over minus x squared plus 1. Something weird happened in this case. Okay, you know very well when the exponent is even number, it's positive. This is 2x squared. But in this case, plus, minus 5, and this is plus. Let me copy the original G before the reflection was 2x squared minus 3x minus 5 divided by x squared. And we compare this, que es the original, and the new one after the reflection. What do you think? Even, odd, or neither? What do you think? Question mark. Even, odd, or neither? Neither! Very well. Because remember, I repeat one more time this idea. It's even when you make a reflection, the function stays the same. Nothing changed. Nothing. And you see that something changed. It's this sign. This sign gets negative here, now it's positive. When you make a reflection, this is even. Odd is when you are doing reflection, it's completely opposite sign. Well. So you see that, for example, this sign changed, but this sign changed, and this sign changed. Entonces maybe it's odd, or in the top or in the bottom, but only one, no? But no, it's not the case. The case is que only one sign changed. Therefore, so because no is no even nor odd. Therefore, it's neither. And unfortunately, when it's neither, we have no symmetric. See, we have no symmetry, so you need to manipulate the positive part completely independent of the negative part. So you need to evaluate in positive value and negative value. Okay. No problem. I try. And finally, additional point. Remember, in my collection of the additional point, I select 3, no? I select 1. I select 1. I select 5. I select, maybe you select all the value, guy. But in my paper, I select this. I don't know why. I don't understand very well the reason why I did that. And you evaluate GN1. This is easy. It's just plugging in. I want to avoid this. It's minus 3. And the point is the point 1, negative 3. G evaluate in 5. The answer is 1.15 positive. It's a 5, 1.15 positive. And in negative 3 is 2.2 positive. Entonces negative 3, 2.2. Si es enough or no, it's up to you. But my recommendation as always is put in decimals. No? In decimals you can see clear everything. Let me switch into decimals. Okay, do you see decimal, right? That was the previous problem. My new problem is something like that. Boom, bada boom, bada bam. Look at that. Okay, it's weird. It's weird because remember, this function have no. Okay. Let me summarize. Okay, in green color, you can see the famous x in the set 2.5, and negative 1, and the y in the set is 0, negative 5. Okay, in green color. En black color, you see the famous point, que es negative 2.3, 2, que was the famous point in which the curve, the blue curve, our function, crossed the horizontal asymptote, que es y equal to, is a horizontal line. And you see actually it's an asymptote. Look at that, look at that. In the end behavior, when you approach it to positive infinity, the curve approaches but never touch the line. In the negative infinity, exactly the same happen. Similar, no? Let me see. Yeah, happen, but for the top part, that is above. Pero it's okay. Entonces, we have no vertical, we have no, make it zoom, let me make it zoom, yeah. We have no vertical. And finally, the extra point, que I select 3, no? Select 5, select 1, and select -3. Yeah, I compute that. Okay, I plot that. The black dot is the open circle. No, open, no. No, open indicates it's a hole, and we have no hole in any problem. Everything is closed. Okay? Super. Good. I like this question. Any problem? Any question, guys? Do you understand very well? So I highly recommend que you memorize or no memorize, you copy in the notebook the procedure. Step 1, step 2, step 3, step 4, 7 steps, no? In total, we have 7 steps. And you organize it that way. Factorization first. X and Y and Z, X and Z, vertical asymptote, horizontal overlap, test of symmetry. Okay. And additional point. Okay, whiteboard. I switch into whiteboard. You see whiteboard? Let me clear whiteboard. Okay, super. Clear canvas. Okay. Let's move on to the problem 3. So today we have 4 problems, and that's it. And with you, everything is easy to explain. Problem 3. Problem 3 is the function, the name is h, is 2x squared plus 9 plus 4 divided by x plus 3. Okay, step 1, factorization. You take the polynomial at the top. Let me try to do the factorization. Let me see, it's close, no? Entonces 8, and a is a and 1, no? A and 1 is 8 times 1 is 8, and 8 plus 1 is 9. So it's 2x squared plus 8x plus 1x plus 4. Now grouping. The great common factor in the first couple is 2x, x plus 4, and the great common factor in the second couple is 1, x plus 4. X plus 4 is a common factor. I factor out. And we have 2x plus 1, 2x plus 1. Okay, this is my new function in factor 4. This h of x is equal x plus 4. It doesn't matter the order, no? Because it's a product. 2x plus 1 divided by in the bottom. It's just an easy binomial primary. We cannot do anything. Any question? Okay, no. Entonces now we can see in that moment que no factor is common. We cancel out nothing. We cannot cancel out nothing. Therefore, we have no hole. No holes. Okay. All is weird, but sometimes happen, no? Okay. What is the step 2? Well, step 2 is find the y-intercept. Y-intercept is evaluate the function h and 0. Well, it's easy because it's 0, we have on the top 4 and the bottom 3 is 1.3. 1.3 repeated. That 0, 1.3 repeated is our 0, 1.3 repeated is our y-intercept. Let me check in my paper. Yeah, okay, super. So we have 1 point, is the y-intercept, and we have, I suppose we have 2 points, que is the x-intercept. Entonces, step 3 is the x-intercept, and x-intercept is when a p is equal to 0, and p is the polynomial here on the top, que is the factor 4, x plus 4. I don't care the bottom part, but I only care top part. P equal to 0, you separate in 2 linear equations, and you solve them separately. The first one is x plus 4 equal to 0, and the answer is -4. And the second is 2x plus 1 equal to 0, 2x equal -1 divided by 2, x equal -1/2. Okay, entonces we discovered 2 points, que es the famous point -4, 0, and -1/2, 0, in which our function crossed the x-axis. And this is called, the technical name of this guy is x-intercept. It's the point when the curve crosses the x-axis. And this is the point when the curve crosses the y-axis. Super clear? You zoom out. Okay, now let's move on to step 4. Step 4 is the famous Bergauss. The Bergauss, what is the formula? It's cube x equal to 0. You take the polynomial at the bottom. Okay, in this case, just x plus 3. Then x equal -3 is our Bergauss. Entonces, guys, I repeat again. This is a crucial moment in which I like to make a sketch to a little bit understanding my function. This is my ordinary number line, infinity positive, infinity negative. This is 0, middle, and -3, -1, -2, -3. We have a vertical asymptote, only one, and in the points -1/2, okay, suppose here, this is 1, this is 2, and -1/2 here, -1/2 here, and -4 here. We have -1/2 the x-intercept. So when I try to select the additional points, well, I select in my paper, I select, let me use in blue color, I select -2, because -2 is in between -3 and -1/2. The one guy, I select totally, maybe -1. I select in after that 0, 1, 2, 3, 4, 5. I don't know why I select 1. Okay, 1. I like 1. And after -4, I select -5. So this is the minimum additional point I select. But okay, I don't forget 2 steps. I forgot 2 steps. Step 5 and step 6. Step 5 is the most important moment, que es the analysis of horizontal asymptote or vertical asymptote, or slant asymptote. Sorry, you want to like both. And the analysis is similar. The analysis is the analysis of the degree. Let me copy again. Our original problem is 2x squared plus 9x plus 4 divided by x plus 3. Okay. Degree of the polynomial at the top is 2. Degree of the polynomial at the bottom is 1. Okay, so what is your conclusion? We have horizontal, we have slant, we have both. I don't know, I am lost. Help me, guy, to understand this problem. When the degree of the polynomial in the numerator top is greater than 1, the degree of the polynomial in the denominator, what kind of asymptote we have? What kind? Slant. Okay, the conclusion of this analysis of the degree, we conclusion that we have a slant. Super. No, special, no horizontal, no horizontal, es slant. Okay, let me repeat again. When I teach in that part, I need to repeat several times because the students don't get the idea for the first time. The horizontal asymptote we have when you have same degree, of course, it's not the case, it's 2 and 1, or case regular, or the degree of the denominator, degree of denominator is just greater than degree of the numerator. Doesn't matter if it's 1 time, 2 times, 3 times. This is the classical idea, and this is special. Special is when there's y0. Regular is when there's y equals something. And slant is when you have the degree of numerator is greater than, pero greater than 1. So it's equal degree of denominator plus 1. Plus 1. Okay? This is degree of 1. 1 plus 1 is 2. Okay. So this is classical slant. Got it? Clear, super clear? I don't need to repeat anymore this idea. You record this idea in your mind. Eso, bueno, Jasmine. Now. Okay. Got it. I got it. However, give a line. No problem. Now, what should I do in order to find the slant asymptote? Okay, you know, slant asymptote is no horizontal. It's y equal mx plus b line. It's oblique line. And horizontal no es y equal b only, a number. We have no slope. Bueno, el slope is 0. It's flat, it's horizontal. But in this case, no. What is the operation that you should do to get this line? I explained the last class. Huh? You remember or you don't remember? Long division. You perform the long division of this polynomial. We can use it as long division or synthetic division. What do you think? We can use a long division or we can use a synthetic division. What do you think? Do you remember that? Okay, you need to do long division. Long division. Okay. In this case, you can do both. Because when you are dividing polynomial divided by, and the divisor, we have degree 1. This is it. You can do by synthetic division. However, I don't know. I prefer long division. In this part, I don't know why in my mind, but it's up to you. You are doing the division. You put in that format of the long division. And you divide. Okay. You divide. Entonces, the monomial que es necesario es 2x. Because when you multiply 2x times x, the answer is 2x squared. And when you multiply 2x times 3 is 6x. By subtracting, you change the sign. This cancels 0, but this is 3. Bring down 4. It's plus 3. Because 3 times x is 3x. And 3 times 3 is 9. By subtracting, change the sign. Now this is cancel again. The answer is negative 5. So I discovered that the original function is 2x squared plus 9x minus plus 4 divided by x plus 3 is equivalent. It's equivalent. The same thing, 2x plus 3 minus 5. Well, in this case, negative because I put a negative in the front, x plus 3. So they're perfect equivalence in between this expression, que es the original, and this one. But in this case, it's super easy to see. It's super easy to see que this represent the slant asymptote. So a slant asymptote is one line like that, mx plus b, and our specific case is 2x plus 3. I discovered que this specifically, this on the y-intercept is 3, 0,3. This is line passing through 0,3. And its slope que es m, es positive slope, entonces es in that direction. O sea, from left to right goes up. Because well, confirmation, pero the thing we know que the vertical asymptote is at x equal minus. But no, this is history. I know. The most important moment, the most important part in that moment is this. Is this line. Okay? But okay. I want to investigate if our function, the original function, this function, cross it or no, this line. Because sometimes happen. Sometimes no, but sometimes yes. It's similar to the horizontal, but sometimes yes, sometimes no. How you investigate this one? Okay. You enforce in this situation, you copy my original function, and you enforce it to be equal this 2x plus 3. Entonces now, see, this equation has solution is because my original function and one specific point crosses this line. Okay, let's do it. This is cross multiplication. You multiply like that, and you have 2x squared plus 9 plus 4. And you FOIL here, your multiplication 2x plus 3 and x plus 3. You FOIL here is 2x squared is 6, 9, 3, sorry. 9 is when you combine, and 9. Okay, my equation so far is 2x squared plus 9x plus 4 is equal 2x squared plus 9x plus 9. Wow, something weird happened here. Look at that. This is cancelled. This is cancelled. And you get this statement is completely false. So what's the interpretation of this? This is a contradiction. This is completely false. This equation, okay, we try to solve it, have no solution. The idea is because in this specific case, our curve never crossed the slant asymptote. Never. Okay, well, the last moment. Everyone follow me? Is it clear or not clear? Okay, another way, another way, not too complicated to visualize this idea. Another way, look at that. Another way, another shortcut. Look at that, look at that, look at that. I copy after the long division my expression. And you enforce it to be equal to x plus 3. So no, the original. No, not the original, not the original. I copy the expression after the long division. By the way, they are equivalent. So this is obvious because this is cancelled and this is cancelled. And I state -5 over x plus 3 equals 0. Now cross multiplication, -5 is equals 0, again contradiction. It's obvious it's impossible because we have 5 here, que 5 is a constant. It's another point of view. Okay. Now, no. The additional point. Oh, no. I skip one step. Step 6 is the symmetry. The symmetry is, let me see. Okay, you replace h for negative x. Okay. And is 2 negative x squared plus 9 times negative x plus 4 divided by minus x plus 3. What the hell is that? Let me see. This is 2x squared minus 9x plus 4. You can leave it like that, or in my opinion, much better like that. 3 minus 6. It's the same, right? And we compare with the famous original equation, that is 2x squared plus 9x plus 4 over x plus 3. So this is the moment to make a decision si es even, es odd, or es neither. What do you think? What do you think? Even, odd, or neither? Even, odd, or neither? Even, odd, or neither? Even, odd, or neither? Guy, are you there? Are you sleeping? Come on. Answer me. Yasmin. Randy, are you there? Andreina. Yes, what? Are you there? Pero you pay attention or no? Here, Andreina is here. Okay. What do you think? Is even, is odd, or is neither? Es what? Yasmin, sorry. I don't see. Cesar, are you there? Queen, are you there? Yancy. Yeah, Cesar says yes, I am. Okay. Es neither. It's obvious. It's obvious. Let me take advantage that moment to explain one idea. Okay. When you're talking about symmetric, even and odd are like a special guys. So a special function are even or odd. The common function, the ordinary function, is neither. So the most frequently case is to be neither. Because even odd are special, sophisticated guys, sophisticated function. Now, I want to do the last step, que es evaluate at the specific point, no? At the specific point, remember the point que I select and the Let me see. Let me check it. I select here in blue color, no? Oh, no. Oh, yes, I select here. I select -5, -2, and +1, no? I select, right? Out. Okay. Okay. So you evaluate in the step 7 in this point. This is a minimum. You H and -5. Okay, you plug in -5. I want to avoid arithmetic part, and you're using calculator. It's -4.5. And the point is -5, comma, -4.5. And evaluate H in -2 is -6. Nice. It's -2, comma, -6. And evaluate N1, +1, is 3.75. 1 comma 3.7. And this is the minimum. So you have no idea when you complete the additional point, you include 2 more or 3 more. It's up to you. Let's see the entire picture in the Desmos now. Okay. Do you see Desmos? Remember, that was the last problem. Now, the next one is this. Bone, butter bone. Look. I copy the function. Remember, okay, the most important point are we have to make it soon. We have y-intercept at the point. There you go. Look at that. This is the y-intercept. This is the y-axis. This is the x-axis. 0.1.3 repeated. This is the y-intercept. This point. Look. This point. We have 2 x-intercept and -4, 0 and -0, 1/2, -1/2, 0.5, 0. Good. Excellent so far. Now we have one vertical asymptote and x equal to -3 is here. That vertical asymptote. Look, this vertical asymptote. Boom. And one slant and 2x plus 3 gets this. This is a slant. And similar situation happened. The curve approach but never touch. Well, in this case, the vertical is impossible to touch because it's undefined. And the slant, we prove mathematically, algebraically, it never cross. And you can see clear. Look at that. Approach it, but never touch. One more important thing. This is the slant. Look at that. The slant. Any question, guys? Any question? No? No. Okay. Let's move on to the last problem. The last problem, I don't know why always the last problem is very, very complicated. But we try to do our best for solving it. Okay. Okay. There you go. Do you see whiteboard? Good. Let's move on to the problem number 4. Problem number 4. The name of the function is f of x is equal x cubic plus x squared minus ax minus 11 divided by x squared minus 9. Well, what is the step one? Well, step one is the factorization. Factorization, pero factorization, the top polynomial was extremely hard for me. I cannot do that. Pero don't worry. I always try. Pero no now. Entonces, okay. I bring this example because you need to be aware. When you try to solve in trinomial, polynomial equation, suppose you put equal to 0. This is, okay, the traditional way I explained was factorization or sign theta division. But this method sometimes is weak. And the problem is beyond this expectation. We need to use a sophisticated technique to do that. How sophisticated technique? Software. I want to explain that. But no. Okay. I try to do by hand. I spend, for example, 2 weeks. Yeah, I cannot. Okay. Entonces I suppose que the zero of this polynomial is maybe irrational number, right? Entonces we have we have formula, but it's too complicated. The formula to the third degree. Then, entonces, professor, we are using this character rule, maybe. Okay, maybe. Okay. But for a moment, I cannot. But the bottom part is easy. The bottom part is easy. Is x plus 3, x minus 2. Okay. So far, my function is I cannot do the factorization. No, definitely. But I create this example intentionally. You see the complication of that problem is sometimes it's super hard to find the solution of the polynomial. I'll leave it like that for the moment. Okay. Let me try now. What is the step 2? Well, the step 2 is try to find the y-intercept. Y-intercept is when the function is 0. It's easy because in the top we have -11 and the bottom we have -9. It's 11/9. Okay, in decimal approximation, I put in my calculator now. 11/9 is 1.2 repeat. 1.2 repeat. Entonces the famous y-intercept is the point 0.1.2 repeat. Okay, this is my y-intercept. Okay, let me copy in my piece of paper. I don't copy that. Y-intercept. No, I did that. It is 1.2 repeat. Okay. What is my next step? Well, my next step is a super complicated step, in which I need to find 0 of the polynomial on the top. Step 3. Step 3 is x-intercept is when the p of x is 0. I need to solve this equation. X cubed plus x squared minus ax minus 11. There are many ways. There are many ways to do that. However, I want to explain both ways. And basically by hand is crazy. Okay, you can spend 2 years doing that. However, we have software. What kind of software? When we have Desmos, no? Pero Desmos is graphical, professor. Okay. We have Wolfram Alpha. Wolfram Alpha. Wolfram Alpha is a software I want to present to you now, and we solve this problem together. It's like a artificial intelligence. Okay, let me try. Wolfram Alpha. Okay, let me share the screen. Do you see Wolfram Alpha? Okay, Wolfram Alpha. So it's easy. I go to my browser. I put Wolfram Alpha. Do you see the Google Chrome page? Do you see or no? Okay. Entonces I put Wolfram Alpha. Wolfram Alpha. Entonces, Wolfram Alpha is amazing. You can use it, guy, en algebra, en cálculos. Wolfram Alpha, fantastic. So you click here. This is computational intelligence. Boom. This is Wolfram Alpha. There are many things, many subjects that go over Wolfram Alpha. However, my interesting part is algebra. I click on algebra. Entonces solving equation, polynomial equation, blah, 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 blah. I select here. Look, select polynomial. Polynomial equation, I select here, pero professor, pero this is not the equation I need to solve. No, I don't care. I don't care. I edit that. This is just example, pero this box is smart and solving any equation. Our equation is x cubic. Edit. X cubic. I no, 23. 23 is too much. X cubic. Plus x squared. The symbol of the power is that symbol. Is the 6 shift 6 square. Minus ax minus 11, no? Minus 11. Minus 11 equal to 0. This is my equation. And you click here to find a solution. Wow. Complicated, but not too fast. Wow, but what the hell is that? Okay. No good. No good. No good. Okay, because this is the exact solution. This is crazy. However, I can, in this computer, I don't know exactly. More digit. Let me see more digit because I want approximation. No exact solution. More digit. No. Fewer digit. Oh, wow. I don't know exactly what happened here. I need to find the approximation. Carajo. Let me see. No exact form. No exact. I need a approximation. In another computer I saw, but in this computer I don't know how you don't find the exact solution. The approximate solution, sorry. A ver, let me see step by step. I don't want step by step. Just enlarge. Approximate form. Boom. Okay, bada bang. Look at that. Okay. No. Well, okay. I cannot show you approximate. Okay. Bigger digit, more digit, enlarge, step by step, no. Random, no. Okay. I don't know what happened here, but yesterday, when I create this example, I solved this. But don't worry. Okay. I find, or you try to do by yourself after. The solution is, look at that. Let me go to the whiteboard. Whiteboard. Okay, do you see whiteboard? Okay, the solution, well, no. Unfortunately, Wolfram Alpha don't help me. Well, in this computer, this is laptop, this is my laptop. However, I have a big computer, because, I don't know, it's just better, I don't know, because this is dependent on the software. The solution is x equal 2.959. Another is x equal negative 1.53. And another solution is x equal negative 2.499. Okay, we have three solutions because the degree of the polynomial is 3. Everything is real, no imaginary, no complex. The first one is positive and 2 negative. Let me try. Well, I can see in this much, definitely in this much. But before to go to decimals, no. I try to understand using the Descartes rule. Do you remember the Descartes rule? The Descartes rule. Let me quickly verification the thing in the Descartes rule. Look, the Descartes rule is something like that. The Descartes rule analyze super easy the chain of sign. This is positive is negative. U is negative. Entonces P and 1. And P means that we have only one positive real solution. Get this. However, when you make a reflection, let's do a reflection is minus x QE. Remember the odd exponent change the sign, they even know. Please change the sign. And this, of course, we have no change the sign. Now, you see here, negative, positive, one change of sign, positive, no change, and positive, negative, two change, n is 2. That means we have two negative solutions, real solutions. This is just curiosity to verification. Okay? Okay. This was the step 3, complicated, very complicated, and incomplete, but I promise that I complete in decimals in your moment. Okay? This is complicated. No, always in mathematics is easy. Always is extremely complicated. Okay? And expanding the idea for proof this number. We are confront this number. Step 4 is the verified asymptote. No? Verified asymptote is easy because you take Q of x equal to 0. And Q was easy, the factorization. Q is positive 3 and negative 3. So basically is x plus 3 and x minus 3 equal to 0. I separate into linear equation. Two linear equation. Negative 3 and the second is minus 3 equal to 0, x is positive. Okay, super. We have two. This is the moment, guys, I like so much to the partition of the x-axis. Okay, x-axis, this is 0 in the middle, infinity positive, infinity negative, and we have in positive 3, 1, 2, 3, 1 vertical asymptote. 3. Vertical asymptote number 1, I call like that, negative 1, negative 2, negative 3, vertical asymptote number 2. Vertical asymptote number 2. And why no? You plot the x in a set que es 2.9 something. Look, okay, you don't know very well where I come from. This guy 2.9 is here, almost here. Wow. 1.53. This is negative 1. This is negative 2. 1.53, approximately 53 here. This is the second point. And negative 2.44, negative 2, negative approximately here. This is 0, 0, 0. We have 3 x in a set. And we have 2 vertical asymptotes. So maybe you select here arbitrary point, maybe 4, maybe 5, maybe 6. And between 3 and 2.9, wow, too hard to find one here. I ignore this. But you select, for example, here, 0 is good. Well, actually, I did 0. Let me select one much better. Negative 1, super good. And negative 2, super good. And negative 4, super good. This is the additional point. O sea, basically, let me enforce it in green color. Negative 4, I select good. Negative 2, I select good. Negative 1, I select 2. Good. 0, no. Because 0, I did. It was the y, and I said 1 and 4. So you evaluate the function. You evaluate the function in negative 4. You evaluate the function in negative 2. You evaluate the function in negative 1. And you evaluate the function in positive 1 and in positive 1, 2, 3, 4, 5. Okay. Okay. But I forgot something important. No? I forgot the step 5. I forgot the horizontal asymptote or slant asymptote. What do you think? Doing the analysis of the degree. What do you think? We have horizontal, regular, special, or we have slant, or we have nothing. What do you think? What is the degree? Analysis of the degree. Let me copy the original function. Again, one more time. Is x cubed plus x squared minus 8x minus 11 divided by x squared minus 9. Degree 3. Es obvio que es slant. Very well. Es degree 3 and degree 2. Ese es slant. Es obvio que es slant. And you know very well that for finding the slant, you are doing the long division. In this case, mandatory long division, no impossible synthetic division, because the degree of the polynomial in the denominator is 2. Synthetic division is only valid when the degree of the polynomial in the denominator is 1. But okay, let me try. X cubed, x squared, minus 8x, minus 11. Divided by x squared minus 9. We are doing this long division. Okay, is x, because x times x squared is x cubed, and x times negative 9 is negative 9, no? It's negative 9, but you're right. Wow. All right. What's going on? Tuning. Okay. This one is tuning to. Okay. Apologize. Okay, entonces you multiply x times 9 is negative 9, but you put here negative 9, no? Negative 9. This is the reason that you manipulate the long division by column. Column of the cubic, column of the square, column of the linear, column of the right-hand side number, so 0 degree. By subtracting, you change the sign here. Okay, and this is cancel. And this you bring down. And this is plus x minus 11. And of course, we continue because the degree here is 2 and the degree is 2. So you stop when you reach and the remainder degree less than 1 less than the divisor. So when you take degree 1. Now it's plus 1. It's obvious 1. Because 1 times x is x squared. And this time this is 9, negative 9. By subtracting, you change the sign. This is cancelled. And this is x, bring down, just bring down, and this is negative 2. Okay. So I discover our expression x cubed plus x squared minus 8x minus 11 divided by x squared minus 9 is equivalent to x plus 1, que es a quotient, look, this guy, I just copy, plus the remainder, que es x minus 2, divided by divisor, que es square minus 9. Okay, this expression is equivalent to the original. But it's clear or it's easy to see What is the participation for the slang asymptote? The slang asymptote is that part. It's slang asymptote. It's always linear function. Slang asymptote. Ajá, entonces es y igual x plus 1. You see que b is 1 and slow is 1. So we are doing the line of the slang. Okay, very, very well. Very well. Very well. Now, I want to see. Okay, I discovered the line, I discovered the slang, I discovered the equation for the slang asymptote. Now I want to investigate if the slang asymptote touch or no the curve. Okay, or cross it, no, touch, no, cross. Entonces, what the complicated way is you copy here x cubed plus x squared minus ax minus 11 over x squared minus 9. And you enforce it to be equal x plus 1. And you solve this equation. The easy way is, suppose you remove the slang, ching chang. Okay, you copy that. You copy x plus 1 plus x minus 2, that is equivalent to the original. And you enforce it to be x plus 1. Basically, you remove this part and stay alive x minus 2 over x squared minus 9 equal to 0. Oh, it's easy. Remember, when you have a fraction equal to 0, it's because the top is 0. The responsibility to be 0 is the top. The answer is 2. Wow. Also, at the point x equal 2, I discover that the curve, our complicated rational function, crosses the slang asymptote. But I need to understand what is the y value. That's 2 comma something. What do you think about something? How we found something? How you find what's the possibility, no, to find the y component at this point? This is a famous point in which the slang asymptote crossed the curve. Help me, guy. Are you tired? Are you tired? Really tired or no? Come on, almost we finish. Almost we finish. Nobody can help me? I think it will you plug it into the Y. But which one, Jasmine? What expression you plug it into where? Here? In this expression? Or in this expression? Well, I suppose que Caesar, this expression, no? You plug it in here, of course you get the same answer. Okay, the easy is here. 2 plus 1 is 3. End the story. Okay, at the point, yes, second, exactly. Second equation is Caesar, is 2.3. Okay, then let me try. Well, what do you think? What do you think about symmetry? Que es step 6 of this function, using the common sense and imagination. Step 6. Remember, is you replace x for negative x. I remember when this odd exponent is changed, when this even exponent stay. So this is crazy. It's obvious it's neither. Yes or no? No necessarily spend too much time in this. It's obvious when you have a combination, odd, even, to say one chain, another doesn't change. To say this is neither. It's obvious neither. It's the most popular case, neither, because it's not special, it's ordinary. And the rest is evaluate in the point que que you obtain, no? In the partition, in the analysis of the partition. Okay, was, remember, positive 4, negative 4, negative 2, negative 1, positive 1, and positive 4. Okay, I want to avoid this situation because it's, okay, it's easy, but it's too long process, right? And you can use a calculator. So let's go directly to decimals to see the final answer. Summarize everything. Okay. Decimals now. Do you see decimal, right? Good. This was the example 7 or the problem 3. Now the problem 4 is this. Bang. Wow. Wow. Okay. Let me analyze. I copy here in the left side the original function. No? Look. This is the original function. The rest was auxiliary contraction. This is the slang asymptote. Look. And we have two vertical asymptotes here and here. Okay. And we have here the y-intercept. But make it zoom. Y-intercept is the famous point 0, 1.2 repeated. It was the result of the 11/9, no? This point. And the other complicated point que we don't know, que Wolfram Alpha give me, pero no en approximate answer, you know, an exact answer, que is very confusing. You click on the curve, look, and you can see, wow, negative 2.429. This is my first x-intercept. My second is negative 1.53,0. And my last third is positive 2.959,0. One more information we have. Well, you evaluate extra point or no, because you see the curve directly in decimals. Very weird. Very weird, right? Let me remove everything. No asymptote. Look at the curve. Remember, the asymptote is a guide que help me to understand, but don't belong to the curve. Any question? In the test, of course, I don't put super complicated example. I put the regular cases, I suppose. And you try to follow the procedure I explained. 7 steps, and that's it. Any question? Any question? No? We can leave? Okay, we can leave. Okay, guys. See no question? You can leave. Next time we start new topic, new section. Okay, thank you.